Hello Internet, my name is Quinn and this is Blondihacks. Welcome to Mill Skills. This is a new series on getting started with the vertical mill behind me there. And if you're new to machining, I'm going to go ahead and recommend you start with my lathe skills series because I think the lathe is the best place to get started in machining. But if you've been using your lathe for a while and you want to bust into the world of vertical milling, well, this is a series for you. Okay, let's dive in. Now, just like on the lathe, the most important mill skill is safety. And that means safety glasses at all times. That means short hair, short sleeves, no jewelry, no dangly bits, no rings, no watches. This, just like the lathe, is actively trying to murder you at all times. Deny it any opportunity to pull any part of you in, and for goodness sake, keep your hands clear of this whole area when that machine is in operation. It really, really wants to hurt you. Don't let it. Wait a minute, you can't fool me. That ain't no mill. Or is it? Well, that was our special effects budget for the season, so I hope it was good for you. So what am I doing here? Well, I'm trying to make a point. My point is that machine tools are all fundamentally the same. Now, we call the lathe the queen of machine tools because, frankly, it can do everything. And that's still true. So why would you ever need a mill? Well, I think the thing to keep in mind is that the lathe can do everything, but all other machine tools are more or less optimizations for common things that take a long time to set up on the lathe. So yes, in theory, you can make large flat things and cut bevels and do all the other things that you might ever want to do on a lathe. However, many of those operations are giant pains in the ass, and so we have mills. The lathe remains the most flexible and the most cleverly designed machine tool. It achieves a maximum precision with the fewest moving parts and with the simplest cutting tools. And for all of those reasons and more, the lathe is still the most generally useful machine tool, and it remains the one that you should start with when you are getting interested in machining. However, let me just get down off the ceiling here and I'll show you what the mill is really all about. So there it is, a very typical hobbyist benchtop vertical mill. And note that word vertical. There are other types of mills. There are boring mills and horizontal mills and various things. But generally speaking, when we use the word mill, we're talking about a vertical mill. And the hobbyist ones are all going to be some variation of this form factor. You might say it's run-of-the-mill. So fundamentally, a vertical mill is so named because the spindle is vertical. And it's just like the lathe in the sense that you've got a spindle that can be precisely aligned relative to the workpiece. Now in this case, the workpiece remains stationary and the cutting tool is spinning, which is different than the lathe. And the reversal of that relationship between what's spinning and what's stationary makes those setups easier on the lathe that we were talking about. So things like creating large flat surfaces or creating specific angled cuts, cutting slots, that type of thing is much easier if the tool is spinning and the work is stationary, more or less. I mean, of course, the table moves, but you know what I'm saying. Vertical mills come in two basic types, and the differentiator is how they manage to move the spindle vertically relative to the work. This is a column mill, which is what you'll pretty much always find in hobbyist benchtop machines. And this guy moves the entire spindle up and down on a column in the back, hence the name. Now, larger floor standing machines are typically knee mills, and they work by moving the entire table assembly upwards to meet the spindle. And that lower assembly that moves is called a knee. And knee mills are generally more rigid because there's more surface area back there and more triangulation in the front to maintain parallelism with the dovetails. So, obviously that's going to be a better choice if you have space. But for these hobbyist benchtop machines, the advantage of a column mill is that, well, it can sit on a bench and the bench doesn't have to move. Now, wait a minute. You might be thinking, hey, that looks an awful lot like a drill press. And I have a drill press, and it was a lot cheaper than a vertical mill. All I gotta get is one of those fancy XY table things to put down here, and I don't gotta buy no mill. I'm a genius. Nobody has ever thought of this. Well, here's the thing. There are two key and therefore expensive differences between a vertical mill and a drill press. First and foremost is the bearings. Drill presses are designed to apply cutting forces only downwards, and what that means is that they use thrust bearings in here, and they're not designed for any kind of side load. And milling is really all about the side loads. You're cutting sideways, and so the bearings need to be designed to handle those types of loads. And then the second reason is how the spindle is secured in here. Mills and drill presses are similar in that they both use a taper to secure tooling in the spindle. And in the case of a drill press, it's typically a Morse taper. But the key difference is that the drill press spindle is held in there only with a taper. So tapers are very good at resisting forces along their length. The harder you push on them, the tighter they seat, but they are not designed for sideways loads. Any kind of sideways load will actually just pop that taper right out of there. So if you have ever tried to do any kind of side loading, milling type operation on a drill press, you learned this the hard way because your chuck fell out. So the key difference with a mill is that it has a drawbar. So the drawbar and the bearings are the two things that make a mill different than a drill press and also expensive. I mean, I'm oversimplifying there. You know, mills are also built much more rigid than a drill press, and they have precise dovetails and table slides and things for moving the work in repeatable ways relative to the spindle and yada, yada, yada. But yeah, those are the two biggies that separate a drill press from a mill, the bearings and a drawbar. And I'm just throwing that word drawbar around like everybody knows what that is. Well, let me explain. This is a drawbar. Every mill is going to have something along this line, and it might be a manually operated one like this, or big mills might have a pneumatic or electrically operated drawbar, but they all do the same thing. Drawbar is a threaded rod that runs all the way through the spindle, and it serves two main purposes. First and foremost, it threads into whatever collets or other tooling that you're using in your spindle, and you slide that guy up in there. And then as you tighten the drawbar, it pulls that guy in. And when you tighten it all the way up, what it does is it seats that taper in the spindle. So that's job one. And then job two is when you come to remove the tool, it will actually also push down on that taper to pop it loose. Because if you've been using that tool in there for a while, these guys can get pretty wedged in there. And so the drawbar will also push it back out again. So that drawbar keeps the taper from breaking loose under side loads, and that's why you can mill on a mill and you can only drill on a drill press. Now for a manual drawbar, you'll need some sort of tool for tightening and loosening this guy. And if yours is a typical hobby mill like this, it probably came with a tool, something like this guy. Now, proper technique with this tool is very important. Step one, and then make up something like this. In this case, this is a 10mm square drive, so I have a 10mm pipe plug socket on here on a socket wrench that lives on the bench next to the mill, and life is very good. Wait a minute, you can't fool me. I've seen this guy on mills, and that looks just like my drill press, ergo, still just a drill press. Well, not quite. So this is the Quill, and it's another way to move the spindle vertically relative to the work. And so you might be wondering, well, why is there a Quill and also a column or a knee for moving up and down? What's the difference? Why is there two ways to do it? Fundamentally, the Quill is a trade-off between rigidity and machinist laziness, or should I say convenience. As you can see, it's a very quick way to get lots of spindle travel, but the trade-off is that the Quill is much less rigid than the rest of the system. So when it's extended like this, your whole setup is less rigid. So if you're doing aggressive cuts or types of milling operations where you need the most rigidity, you want to keep this Quill all the way up, keep the Quill locked, and use your column or your knee to get your vertical travel. So what good is the Quill? Well, there are lots of operations that you might do that don't require maximum rigidity. So if you're taking light passes, or if you're milling aluminum, or for example, drilling, just like on the drill press, the Quill is great for all of those. And the fact of the matter is, moving the knee or the column for all of your vertical travel is a ton more work. So typically, you're going to use the Quill as much as you feel like you can get away with. Now, a key difference, though, on the Quill from a drill press is that there will typically be a coarse feed and then also a fine feed of some sort. In this case, there's a worm drive here on the front. And this is very important for getting accurate depths of cut. And in this case, there's a DRO on this Quill, so you can see exactly what kind of depth you're getting. And then typically the fine feed will be some sort of worm drive, so it has zero or minimal backlash in it, which is also very helpful. So people new to the vertical mill often wonder, well, okay, what's the right mix then of Quill and column or knee usage? How do I use each one and when? Well, for most milling operations, generally what you want to do is get your column or your knee kind of in the ballpark of where your cut is going to be. You know, maybe give yourself enough room to get the cutter in and out, and do your cutting generally with the quill mostly retracted. And then as you do each pass, you know, you're going to drop it down 20, 30, 40, 50 thousandths, whatever. That depth change that you're doing on your different passes, you can do that with the quill. And if you're milling, just make sure to lock the quill with each pass just to get the most rigidity out of it that you can. But even with the quill, the most precious resource on any vertical mill is your vertical real estate. There never seems to be quite enough space in here. And so the quill will give you, 2 or 3 inches of wiggle room on your travel, but like it or not, you're going to end up moving the column or the knee up and down quite a bit. And on a hobbyist column mill, that means you're going to be reaching back here for this column crank quite a bit. Your right shoulder is going to get buff, so just get used to that. So the mill itself just has a spindle, and the service it provides is to spin that spindle at whatever your desired RPM is with good rigidity against lateral loads. Everything below here is your problem. Okay, so speaking of milling cutters though, how do we actually hold them in here? All we've got is an empty taper. Now I know this seems reasonable, but it doesn't actually work as well as you'd think. So any tooling you put in here needs to have a taper on it that matches your mill. So a very common way to put stuff in there is going to be a collet. All right, so holding our milling cutter in a collet is very simple. Just seat that collet in there and tighten down the drawbar. And if you wondered why fancy mills always have pneumatic and or electric drawbars, this is why, because you spend a lot of time doing this. And then once your collet is kind of all the way in there, you'll feel it kind of seat on the taper a little bit, and then you can go ahead and insert your milling cutter and then tighten that guy down like so, and then give it the final snug with your spanner. And you're ready to mill. Now different mills have different tapers in their spindles, but there are a couple of very common ones. The most common is the R8, like this guy, and you'll find this on the vast majority of mills, but some larger machines or like horizontal mills will use like 40 taper or 50 taper, so there are other common ones as well, but something like an R8 is going to serve you really well. And of course you have to make sure you're getting collets that match your spindle taper, and they have to have a drawbar in the back. Now the drawbar threads themselves are standardized to the taper dimensions. You don't have to worry about that matching, but the key difference with spindle collets like this guy is that they have a place for the drawbar. There's no through hole compared to like a 5C collet, for example, which has a hole all the way through and can hold stock. So don't confuse your mill spindle collets with general work holding collets. Now there are other options for holding milling cutters. One of them is an end mill holder, which will have a taper that goes in there, and it'll make use of this flat spot on the end mill for a set screw, and that'll give you a more secure hold for, very large end mills. But on a small hobbyist machine like this, you're really never going to need that. End mill holders are expensive, and I've never had any trouble using a collet. So collets are your friend for the hobbyist shop. Now, other types of tooling might use an arbor, such as this big shell mill. You'll also see this with face mills and other larger tooling. And so this guy will have the taper built into it like this, and it'll have a place for your drawbar to thread in, and then your cutter or whatever will thread onto the end of the arbor. And so this whole assembly slides into your spindle, and you find that key again, and then once again, tighten that up, and away you go. And once again, to get this guy out, you are likely going to have to push down with the drawbar to pop that taper. And then there's our old friend, the Jacob's chuck, which is as useful in the mill as it is in the drill press. And similar to the arbor, it's got its own shaft here with the matching taper and a place for that drawbar to thread in. And that guy slides in there just like the arbor did. Find the key, and then tighten that guy up. And the Jacob's chuck is where you really start to feel that vertical real estate. So you can imagine trying to get your workpiece in here and also a room for a drill, and we're running out of space pretty darn quick. So with the Jacob's chuck on a small hobbyist mill, you're generally going to have to crank this guy up as high as it'll go. And then that leaves you room with your quill to do your drilling operations and what have you. So yeah, vertical real estate, very precious. Now at this point you might be thinking, hey, I don't need all that fancy tooling for holding end mills. This here Jacob's chuck is designed to hold these guys, And these look an awful lot like these guys. So what if I just... Bad machinist, no cookie. Okay, so what's the straight dope on putting an end mill in a Jacob's chuck? Why can't you do it? There's a bunch of reasons. First is hardness. Now, while these guys are both high-speed steel, assuming this is a quality drill, the end mill actually is much, much harder than the drill. And Jacob's chuck jaws are also very, very hard. So it's kind of like two pieces of glass trying to grip against each other. You're going to get a very poor grip on the shank of an end mill with Jacob's chuck jaws. Second reason is lateral loads. Jacob's chucks are designed for drills, and so they're only designed for upward forces on them. Lateral loads on these little jaws would make them very sad. You don't want sad Jacob's chuck jaws. And even if all that wasn't reason enough, the other is frankly just rigidity. Jacob's chucks are not as rigid as other types of tool holding, and look at all this length that it's adding to the end of your spindle. Imagine this end mill way down here and lateral loads down here. You're losing a ton of rigidity, so you would never want a side-loaded cutter this far from your spindle in any case. Old machinists tell tales of the greatest machinist who ever lived, and she was so because she had 3 hands. There are many operations in machining that really seem to require them, and removing your milling cutter is one of those. Here's the problem. If I go ahead and loosen the drawbar right now, I've got one hand on the drawbar wrench, I've got one hand on my spanner wrench, and well, what's going to happen? The milling cutter is just going to fall right out of there. It's going to damage the work, it's going to chip the cutter. Chaos ensues, cats and dogs living together. So when you're first starting out, just go ahead and put a board or something down there to protect it, just in case the cutter does fall out of there. But there is a technique to avoid needing a third hand here. You can just put your spanner wrench on there, just kind of put a finger on that milling cutter, keep it from falling, and then loosen up your drawbar. And then when you just break that drawbar loose, the milling cutter won't actually fall. The collet is still holding it. So then what you can do is just grab the milling cutter and the spindle with your hands, and then loosen it all the way, the rest of the way. And in fact, you can see it still doesn't actually want to fall because the collet hasn't been popped off of that taper yet. So there's going to be a point right here where it pops the taper, and now you can take the cutter out. So this technique takes a little bit of practice, but it'll save you a ton of time, and you won't drop milling cutters on your work. And of course, I can't leave you without talking about the table. Much like the lathe, there's a stack of slides here, and in this case, they move the work relative to the spindle instead of the lathe where you're moving the tool bit relative to the work. But it works much the same way. There's gibs and locks on each slide for those times when you need extra precision or extra rigidity. And there are markings on the crank for measuring your travel. And then there's also a movable collar so you can zero these guys out. Now, also like the lathe is some bad news, and that's of course backlash. Any mechanical system has backlash in it, and the mill table is no different. And like the lathe, this is not a sign of poor quality, this is just physics. Now, unlike the lathe, however, backlash is a real pain in the butt on the mill, because on the lathe, it doesn't really affect you that much. You know, you're only generally moving in one direction during a cut, and it's very easy to simply get into the habit of winding out and winding back in before you start a new cut. Really not that big a deal, it's just a little bit of muscle memory. The mill, however, you are often doing cutting operations in multiple directions, and every time you change direction, of course, now you're into backlash town, population U, and all of your markings are now meaningless. So if you're going to go old school, I applaud you, but you will have to get very comfortable with backlash and understand how to compensate for it, especially when milling things like squares or when you're milling back and forth. But wait, there's a better way. It's called the digital readout, or DRO. Now, these guys are a real luxury item for a lathe, but I honestly believe that for the mill, these guys should not be considered optional equipment. And the old-timers are going to laugh at me for needing a DRO, but honestly, these guys are transformative for your quality of life on the mill. Now, fundamentally, it's just like having hand wheels with no backlash in them, and that's great, and that's frankly enough value on its own. But it also gives you all kinds of other powers. It lets you find centers, and you can make bolt circles, and you have multiple coordinate systems for different fixtures and for measuring travel without losing the origin of your part. You know, all these sorts of things. I would honestly consider the DRO required equipment on a vertical mill. And you know, with these Asian import DROs, they're really quite inexpensive, and it is absolutely worth your money. Plus, if, like me, you're working on English as a second language, the manuals for these things are a great exercise. For example, to clear 200 sets SDM datum, in ABS mode, to continuously press the key dot 10 times will cause to clear all the datum for 200 sets SDM. I understand. Thanks, manual. And while we're on the subject of spending more money than you want to, the other area that I think is worth splurging on is the Vise. Everything you do on this machine is only as precise as this vise, and buying a high quality vise is really going to make your enjoyment of the machine a whole lot greater. And so yeah, it's really worth spending as much as you feel comfortable on this guy. But when choosing a vise, do be mindful of this vertical real estate once again. For example, don't be like me and get seduced by these swivel bases on vises. This thing seemed really great. Oh, I'll be able to do angles and, you know, not have to reset my vise all the time. But yeah. This thing lasted about a year before I got rid of it, and it was one of the best things I did because this extra couple of inches of height that it takes up makes all the difference with longer drills and some of those other operations when you just need another little bit of extra space. So yeah, think twice about this guy. And finally, if there's any way to fit it into your budget, do definitely also consider a power feed. You will spend a lot of time cranking that x-axis back and forth, and this guy, especially a model that has rapids, will save you a whole lot of tiresome cranking. But this is also something you can typically buy later and add it once you get tired of cranking. In my case, I think I lasted about 2 months before I splurged on the power feed. So those are the basics of the vertical mill. Now, of course, there's a ton more to learn about work holding, fixturing, different types of cutters, and so on. But we will be getting into all of that in later videos in the Mill Skills series. So thank you very much for watching, and we will see you next time.